Okay, hey everyone. I know I'm a bit late to this. As you probably saw in the bottom corner of my screen, it's about 8:30. Um, I've just been very busy the entire day, and I've only gotten a chance now uh, to record my review on the 2026 Maths Paper 1 that was sent earlier this afternoon. I'm going to be reviewing the Maths Paper 1 for both higher and ordinary level, as well as the Junior Cert paper, just the higher level, just so my grad students can kind of hear well, I'm a day students as well, can hear slightly more about the paper and my thoughts on it. Now, I have had a look at it, and I can explain it in one word in that the entire exam paper was strange, to put it one way. And I'll do that just by reviewing the questions. Now, the first three questions were definitely sort of a competent junior cert student could do pretty well. So we have this equation, so move the 1 over and square both sides, that's fine. And rearranging for p. So not too bad. Move it over, common denominators, swap them around and multiply by 2, so that's okay. And then some pretty nice root factor theorem questions. So question 1 is a delight. Definitely something to kind of ease your nerves. Then this happened. We hadn't seen this in a while. This was on one of the previous SEC papers, as far as I remember, but hasn't been on there for a while. I think it was 2015, though I feel like I'm going to eat my words when I say that, but it hasn't come up in a while. So a bit odd to come up with that. And then a fairly okay loan repayment question. Here you can just use the amortization formula because we're paying off the loan. So that we can use. I'd say the entire exam hall was laughing when that was the monthly interest, though I definitely know some students that were possibly cackling when they saw that because they think they're comedians. Question 3 started off with a pretty nice product rule. Did have to use chain rule on the cosine of x, but that's fine. And then some more stuff about the second derivative. By the way, for this x and g of x, obviously we have the slope of the tangent, which we can work in, but also minus 1 comma 8 is on g, so that will get you the information you need to find g of x. A beautiful complex numbers question. I was practicing a lot of this with my students, especially parts A and B. So utilizing the conjugate, and then using Moivre's theorem to expand a complex number. They're both pretty fine. And this one was a bit strange. It did require a little bit of thought, but I think once students were able to crack it, then it was totally okay. You just kind of had to mess around with theta a little bit just to make all the numbers work. Of course, the modular are just going to be 5 and 3 because when you multiply them together, you should get 15. Then you just mess around with theta until stuff kind of pops out. Question 5, again, seemingly sort of junior cert-esque question. I mean, like maybe apart from the first one, but it definitely led into a bit of a weird part B. And then part C was probably the easiest exponential equations question of all time. Now, we were expecting induction for a little bit. It appeared on last year's paper, but excuse me, chicken gyozas are coming back up. So yeah, induction was on one of the long questions last year, so we thought that was a bit of an anomaly. So in terms of looking for induction, I'd say this is pretty okay. I know a lot of students actually struggle with inequalities in induction, but this is a pretty standard one that you might have been taught initially, or something to kind of this extent. And continuing the theme of factorials, we now have a factorial equation. You just have to find a way to cancel the n minus 1 factorials, which is pretty okay, and then it's just a quadratic. And then a sequences question, which required quite a lot of thinking and sort of just testing a couple of things, because we're looking for a possible geometric series with these restrictions, and of course you could go numerous different avenues to solving that. So overall, the short questions had a nice mix. There were definitely questions in there that the students just looking to pass would have definitely found quite nice, and some students really some questions to really challenge the students who put quite a lot of effort into studying maths over the past 2 years. So section B is starting off with a fairly regular differentiation question. So we have a tank of water, finding a volume, then finding a rate, so that's pretty standard. investigating what times is decreasing. Again, pretty normal. Then we have related rates popping up. So obviously we have dv/dt, and we're looking for dv/h, so you can maneuver through that pretty nicely. Giving your answer in centimeters per second, that's okay. Then we have this expression for c in terms of h, and we're looking for a local minimum, so of course you just set the derivative equal to 0, and then use the second derivative test just to make sure that the value you get is actually a local minimum. Second derivative being positive will tell you that. And then C of H is defined for that. Yeah, that's effectively just a restriction question because they don't give you the restriction. You're asked to find it yourself, which I thought was pretty nice. A lot of students would have just completely ignored the restrictions beforehand. But I definitely made it a thing with my students that anytime you're looking for divide by 0 errors, just make sure that you note that you can't have those particular values. In this case, you just set C of H, just effectively looking for the places where it can go wrong. Okay. Now, question 8. Oh, question 8. This one was fun to look at. It had a bit of a weird start in that piano tuning frequencies was something I was pretty accustomed to in terms of studying. So this question kind of shocked me when I saw it for the first time. But two pretty okay beginnings. And then C and D were actually also okay. The issue started to arise in parts E and F, where this was again a conceptual question more than here's G, here's G prime, do something about it, and in sort of a computational setting. But this was just kind of guesswork. So, you could say that G of K plus 2 is just 2 derivatives up because that's how much the function is changing on average over time. But of course that isn't always constant, which is what part B entails, in that you can have exponential growth but also exponential decay, and then things can actually be slightly different. Now I haven't actually sat down to do the questions properly. I'm actually just having a look over them. It'll probably be at some point in the weekend, so a little bit later than usual. I presume all the other maths channels have their solutions already released. But I'll just leave it for the time being. And then part F was seemingly a 4-variable simultaneous that you could pretty easily work out because a lot of it is just purely subbing in to fairly straightforward equations. All of them have, say, like, twice the number of sopranos minus the number of altos, etc., etc. It's actually not terrible. Now, question 9, sequences question here. This is a bit of an odd sequences question, I thought. Sequences questions in general tend to be a little bit off-piste in terms of what they talk about. In this case, it was some exercise. And then this question here, I remember staring at, just trying to make sure I read everything twice because it was very word heavy, as you can evidently see. The entire paper the entire section B, Jenny Mac section, was very word heavy. And then this. So the question started actually pretty nicely. It started fairly innocently, just making sure we knew how to shift graphs up, down, left, right. Then periodicity of a non-trigonometric function, which was pretty okay. You just had to effectively use your normal definition of period. That's fine enough. And then some nice integrals. And then this question here effectively tasked you at noting that you can split this integral into 2 separate things. You can integrate j of x and then plus b times the integral of 1. So that was actually okay. And then some more maneuvering of functions. So that looks like it's been expanded already, which is kind of okay. So yeah, the end of that question was a bit odd. Just kind of look at. So from a purely seeing the questions point of view, this was very strange. A lot of the questions hadn't come up in a while, so they tended to ask pretty much everything they haven't asked in a while and just kind of throw it on the one paper. I'd say a competent student might scrape a H1 because a lot of the parts are actually conceptually quite challenging and have a lot of words to them. So those who were good at synthesizing questions might have found this a pretty decent paper. So note that's all behind us now. I will provide my attempt at solutions again at some other time. But for now, we'll leave that behind us and we'll focus on paper 2 from Monday morning.